Hi everyone, I am Azana Khalil and today I'll be discussing about virtual reality. And these are our contents. Today I'll be discussing virtual reality and its history, core technology, applications, challenges, and where VR is headed in the future. Let's dive right in. Virtual reality or VR is a simulated experience that can either replicate the real world or create a completely different environment. VR immerses users through visual, auditory, and sometimes even tactile feedback. What started as a concept in science fiction has evolved into a practical technology with broad application across gaming, education, healthcare, and more. Let's say early beginnings of VR. VR has come a long way from its early beginnings in 1962. Morton Healing created the Sensorama, one of the first devices aimed at providing an immersive experience using visual, auditory, and olfactory inputs. Early VR devices were limited by the mechanical and analog technology of their time, but they laid the groundwork for what was to come. And in the digital age, in the 90s, 80s, and 1990s, brought significant advancement in VR technology. The iPhone by VPL Research, created by Jaron Lanier, was one of the first head-mounted displays that used computer-generated graphics to create immersive environment. While the technology was still in its infancy, these developments marked a pivotal moment in VR history. And in the modern era, in the 21st century, rapid advancement in computing power, graphics, and user interfaces design propelled VR into the mainstream. Companies like Oculus, HTC, and Sony developed consumer grade VR systems. With the Oculus Rift, HTC Vive, and PlayStation VR becoming benchmarks for immersive experience. And here are the core components of VR technology. VR technology relies on several core components. Head-mounted displays provide a stereoscopic 3D view with sensors for head tracking, motion tracking sensors, and controllers allows users to interact with the virtual environment. Software and game engines like Unity and Unreal Engine are critical for creating 3D environments and interactive scenarios. And let's look into the role of computing power. VR demands significant computing power, particularly from GPUs and CPUs, to render high resolution graphics and process inputs from multiple sensors in real time. Real time rendering is essential for delivering a smooth and immersive VR experience, making powerful hardware a critical component of modern VR systems. And let's move on to the next slide, the application of VR gaming and entertainment. VR has revolutionized gaming and entertainment by offering unparalleled immersions. Games like Beat Saber, Half-Life Alyx allow players to step inside their favorite worlds. Beyond gaming, VR is transforming entertainment through virtual concerts, theme parks, and interactive storytelling, providing new ways to engage audience. And let's move into the left side. Here is in education, VR creates interactive and engaging learning environments. For example, students can practice surgical procedures or explore 3D models of machinery. And these are the application of education and training, and VR is also used in professional training simulation for military, law enforcement, and companies offering realistic risk-free training in a controlled environment. And let's see the application of VR in healthcare. VR has significant applications in healthcare. Surgeons use it to practice complex procedures, reducing the risk of errors. VR also helps distract patients from pain and anxiety during medical procedures and is used in treatment for phobias, PTSD through exposure therapy. Application of VR and architecture and real estate. In architecture, VR allows for virtual walkthroughs of designs, enabling client to experience and modify spaces in real time. Real estate agents use VR to offer realistic tours of properties, enhancing the buying experience without the need for physical visits. And these are the challenges and limitations of VR. Despite its potential, VR faces several challenges. High quality systems are expensive, making them less accessible. VR sickness caused by a disconnect between physical movement and the virtual environment is another issue. The creation of high quality content requires significant resources, and current technology is limited by factors like field of view, resolution, and the weight of headsets. The future of VR is exciting with developments such as wireless and standalone systems like Oculus Quest, which eliminate the need for external sensors and cables. We can also expect improved resolution and field of view along with enhanced interactivity through advanced input methods like eye tracking and hand tracking. Integration with augmented reality Integration with augmented reality and mixed reality system will further expand the possibilities for immersive experiences. In conclusion, VR has evolved significantly and offers wide-ranging applications across various industries. While challenges remain, the potential of VR is immense. As technology advances, VR will play an increasingly significant role in shaping the future of entertainment, education, healthcare, and beyond, transforming how we perceive and interact with the world. Thank you for your time. I hope this presentation has provided you with a comprehensive overview of virtual reality. I am happy to answer any questions you might have. Thank you so much.